Howdy, my name is Oscar Humphrey, and I'm the team lead for Team AeroMech, a team in Texas A&M University. And this is our project for image recognition AI system for fault detection in spacecrafts. The future of space exploration and development has become a topic of growing interest among visionary engineers and industry leaders. Companies have begun to produce multiple spacecraft in short time spans, and it is imperative to check that the safety and stability of the spacecraft is good before launch. The problem is that some angles and positions that need inspection are unsafe for people to reach themselves. Spacecraft maintenance is difficult in environments that are dangerous or inaccessible to people such as space. Failing to detect faults ahead of launch can lead to tragedy, engineering disasters, and costly redesigns. The solution is a spacecraft fault detection system. It uses machine learning and sensors to assist in identifying any potential faults of a spacecraft using image recognition. The SFDS uses data from the spacecraft regarding its structure to evaluate any possible faults through comparison of a good and bad structure from its database. Our project consists of 40 frame material, which allowed us to create the 40 spacecraft model, the 40 electrical elevator powered by a stepper motor, an elevator with a camera attached, and then the SFDS image recognition program. The AI machine learning application for this project. The AI model uses a module called YOLO, which is a real-time object detection algorithm that identifies an object and annotates it. The model can recognize based on what data was given. This can be done using RoboFlow. RoboFlow gives the ability to provide custom data to YOLO and trains the model based on the amount of data given. Using YOLO RoboFlow made this project possible to detect the 40 frame material and make inferences to the 40 spacecraft model. As you can see in the image to the left, it's training the model RoboFlow, where the user annotates and trains the model based on the level of the rocket and then the color of the tubes. And on the right side, you can see the model output, where it would annotate based on what the model was trained. The system uses three phases. The first phase is positioning. The elevator camera system is controlled by the user, positioning the elevator so the camera inspects the desired level. Phase 2 is scanning. When positioned, the camera is activated and starts to capture images, and the AI model begins to recognize the features of that level of the spacecraft. And phase 3 is evaluation. After recognizing the level, the model evaluates whether that particular level is good or bad by comparing it to the data it was trained on. In this case, it was the color of the tubes. It is up to the user to define these conditions so that the system provides an accurate evaluation. Now for the project demonstration. Scenario 1 is level 3 of the spacecraft, which is good. By good, it means that all the correct pieces are present in the level being observed. So in phase 1, I positioned the elevator so it can be at level 3's height. Once the camera's positioned, it opens and starts scanning the area. As you can see, the AI model begins to evaluate whether level 3 has all the necessary pieces. If it does, then it will annotate as good, as you can see in the video. Scenario 2. Level 3 of the spacecraft is bad. By bad, it means that there is an incorrect piece present in the level being observed. So phase 1, the elevator is already positioned at 3, so it will stay, and then it will start opening the camera and start detecting. So as you can see, there's an orange piece there, so the model will annotate as bad. And that is the image recognition scenario. Here are additional demonstrations. So image recognition for level 1 and 2 is good. As you can see, it sees that all the correct pieces are there, so it will mark as good and see the orange and black tubes. And on the right side, you can see the image recognition for level 1 and 2 is bad, which it will detect 1 and 2 being bad based on the incorrect colors. And this additional demonstration is the elevator control using the control system. As you can see in the program, the user types either up or down to make the elevator go up or down, or stay to stay in that position. If it's going up or down, it will prompt the user to continue moving. So if you press Y, it will continue moving to that direction. And if you press N, it will stop moving and begin capturing footage and start making the evaluation. And that is our 40 frame presentation demonstration. Thank you from Team AeroMech. And these are the team that worked on, including myself. We worked on the 40 elevator tower and pulley system. I worked on the AI program 40 model spacecraft, and the other member worked on electrical systems. Thank you.